Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is M.Pd. In this time, I will discuss about how important is relativity. So, let's get started. Okay, the second slide, there are the number of things that we will discuss, namely definition, descriptions and example, classifications, sequence, comparison and contrast, cause and effect, problem and solution, and the last persuasion or evaluation. The third slide is definitions. How is relativity important? In the field of physics, relativity improves the sense of elementary particles and their fundamental instructions. Along with usury in the nuclear age, with relativity, cosmology, and astrophysics predict extraordinary astronomy phenomena such as neutron stars, black holes, and gravitational waves. What is the simple definitions of relativity? Relativity is the word for how things only have importance in relation to other things. In physics, relativity refers to Einstein's theory that time and space are not absolute. If you believe they are absolute, correct answer to everything, you probably don't like relativity, which is the opposite of absolute. The next slide is description and example. The importance of special theory of relativity is that it helps us understand time and space more. The special theory of relativity describes how to observe, view each other's motion in situations where gravity does not play an important role. For example, a fast-moving person measures time passing more slowly than a relatively stationary one, and a fast-moving object appears shorter than a slow-moving one. Special relativity also produces the most famous equations ever written. The fifth slide is classification. In physics, it appears that physical objects are endowed with many different physical properties, each of couples to a physical fit that the specific physical law that can be described by a particular system partial different equations. It is also conventionally assumed, due to our ability of observing and previewing of the natural environment, that physical events occur in the three-dimensional space and progress forward and backward in time and occur in higher dimensional space. From the physical laws, they are derived and formulated from observation. A mathematical structure of space and time can be struck to conform to the corresponding oversight physical occurrence. In Newton physics science, the established dynamical laws we describe the dynamics of material particles seem to obey the plane in transformations of space and time. Therefore, it is reasonable to assume that time is absolute. On the other hand, in Einstein physics, space and time, the relativity sign it is established that makes field equations of the electromagnetic field complete with the Lorentz transformations. The sixth slide is sequence. General theory of relativity. In the general theory of relativity, Einstein explained that gravity exists as part of space and time. Gravity does not exist, but is the result of the curvature of space and time caused by the existence of a mass quantity. And then special theory of relativity. As already mentioned, relativity believes that the laws of physics and also the speed of light are absolute, while space and time are relative. Einstein discovered the special theory of relativity, which is held to postulate. The seventh slide is comparison and contrast. Comparison of relativity is a fundamental theory in physics that describes behavior of objects and nature of space-time. There are two major branches of relativity. Number one, special relativity. Special relativity formulated by Einstein in 1905 deals with the behavior of objects moving at constant velocities, especially in the extent gravitational force. Introduced two key principles. Special relativity leads to several remarkable consequences, such as time dilation, length contraction, and the equivalence of mass and energy, expressed by famous equation. It is also established that no information can travel faster than the speed of light. And number two, general relativity. General relativity developed by Albert Einstein in 1915 expands special relativity to include relativity. It provides a geometric description of relativity as the curvature of spacetime caused by mass and energy. In general relativity, the motion of objects is determined by the curvature of spacetime. In summary, special relativity deals with the behavior of objects in the absence of gravity and introduces concepts like time dilation and the constancy of the speed of light. General relativity expands special relativity to include gravity and provide a geometric framework for understanding the property of mass and energy on the curvature of spacetime. Both theories have been extensively tested and confirmed experimental observations and play a crucial role in modern physics. Experimental confirmations. Special relativity. Special relativity has been extensively confirmed by various experiments, such as the Maxwell-Morley experiment, which is demonstrated the constancy of the speed of light and measurement of time dilation in particle accelerators. General relativity. General relativity has also been confirmed by several experiments and observations, including the bending of sunlight around massive objects, the precession of Mercury orbit, and the existence of gravitational waves, and the redshift of light in gravitational field. While special relativity and general relativity are distinct theories, they are both consistent with each other within their respective domains of applicability. General relativity reduced to special relativity in instructions where gravitational effect can be neglected, such as in regions of weak gravitational field or for objects moving at speeds much lower than the speed of light. Okay, the next slide is cause and effect. Physics in trying to observe what exists and how it behaves. This can be done by observation and fitting models to the observed. Answering questions about why something exists in metaphysical question and not amenable to the scientific method. This way least religion because God made it that way, or because the back of the turtle that we stand on is curved. Relativistic effect on time, distance, and momentum. Consideration of the measurement of elapsed time and simultaneity leads to an important relativity effect. Time dilation in the phenomenon of time passing more slowly for an observer, how is moving relativity to another observer. Next slide is problem and solution. The theory is not basically concerned with a comparison between different observers, but between different coordinate systems which are available to a single observer. It is not basically concerned with a comparison between stationary and moving systems but between descriptions of a single system with respect to different arbitrary chosen standard of rights. The instant field equation relate the instance to the stress energy tensor, which represent the distribution of energy, momentum, and stress in the space-time manifold. The instant tensor is evolved from the tensor in its partial derivations. Thus, given the stress energy tensor, the instant field equation are a system of the partial differential equation in which the metric tensor can be solved for. And then last slide is persuasion. GPS and space exploration, the theory of relativity, particularly the concept of time dilation, is essential for accurate global positioning system. Calculations. Without accounting for the extent of relativity, GPS relativity plays a crucial role in understanding the behavior of celestial bodies, such as the motion of planets, stars, and galaxies. Insight into the universe. General relativity provides profound insight into the nature of its health, skin understanding the large-scale structure and dynamic of the universe, contributing to our practical applications in various fields. For example, the development of technologies based on gravitational wave detection has opened up new avenues for studying astrophysics and fundamental physics. The relativity theory also contributes to the development of advanced navigation systems, space exploration, and the design of satellite communication systems. Supporting the theory relativity allows us to comprehend the fundamental nature of space, time, and relativity, and it provides a robust framework of scientific advancement, technological innovation, and our understanding of the universe at large. Okay, I think enough from me. Thank you for watching, and I hope what I say can understandable and useful. Thank you. See you on the next video. Wassalamualaikum warahmatullahi wabarakatuh.